If you like this video, make sure to visit our Vimeo page and follow us to get the latest update.
Okay, so let's begin with the session then. So like you guys already know, around 50 to 60% of the data that we get are text. They are unstructured data sets, right? They are not in a structured format. Like we get data sets in the textual format. For example, it could be comments from any e-commerce websites like Flipkart or Amazon, any of the websites like that, right? Otherwise, it could be tweets or Facebook posts that you guys might want to analyze, right? So since all these data sets that we get will be in the form of a text. So NLP is one such domain in data science which can help us to deal with such data sets, right? It actually gives us so many techniques using which we can actually extract a lot of details from that data set. All right, great guys. Okay, so like I was saying, so NLP actually gives us so many techniques which we can use to extract the information from the text data set, right? So so what do we basically do? So whenever I'm just giving recapping the NLP basics so that you guys will not get confused with today's topics, right? So what do we do whenever we get any text data set? So the first thing is we need to pre-process the data sets. Pre-process the data set that we have, because the the data set which is in the text format will not be clean at all. For example, the spellings might not be correct in the data set, or the data set will not be in sync. For example, there could be a small AND and there could be a capital AND. So the system doesn't recognize those two as a single word. Okay, it will consider that as a two different words. So what we need to convert everything into into one format itself. So that's where conversion of all the words into small lowercase comes into picture, and then spelling correction, and then lemmatization and stemming, where we bring down the words to its root word, right? Because both good and better and best, everything is same. They are conveying the same message, that the product is good or this person is good, right? So we want to bring down the words into root words so that we do not have too many redundant words in our data set, right? So that's where lemmatization and stemming comes into picture. So all these pre-processing steps has to be performed on each of the data set, because we want to keep the data set clean, right? Because as we already know, whatever data you feed into the machine learning algorithm will be given to you like that. For example, if you feed junk data set into your machine learning algorithm, the results given by the algorithm will also be junk in nature, right? It will not be correct at all. So you have to make sure that the data set, whatever goes into the algorithm, has to be as clean as possible. Okay, so that's why we perform all these basic text pre-processing. And then if you want to build any classification algorithm out of it, for example, email classification, which I'm sure you guys might have already implemented in Python. So we want to build a classification algorithm over there, right? So what do we do? First, we perform all the pre-processing steps, and then we convert these text into features, because machine learning algorithms understands only numeric data. So if you just feed the textual data into that, it won't understand it, right? So that's why text to feature comes into picture. We'll convert all the text into features, and then we will feed those features into the algorithm, which then predicts whether the mail is, it's a spam or ham mail, right? So all these things you guys have already, learned in the previous classes. So I just wanted to, recap all those things, right? So in today's session, we will be studying 3 to 4 additional topics, which, even these are actually NLP techniques, which we can actually use on the text data. Okay, so the first such topics is n-grams, right? So what is this n-grams, and where can this be used? Okay, so here you have a sentence here, right? Sentence is a contiguous sequence of n items from a given sample of text or speech. Okay, so now let's say we want to perform some analysis, like we want to predict whether this sentence is positive or negative, right? So I'll just take it to or else I'll give some other example. Okay, so let's say there is a new phone has been released into market, into an Amazon website, and there are many people commenting on it. Okay, so let's take one comment as an example, saying that the phone's battery is not good. Okay, so we have a comment like this in the comment section. So now you want to find out what is the sentiment of this sentence. So sentiment in the sense whether this statement is positive or negative, right? So by default, you can easily understand that the statement is it's a negative in nature. But so whenever we are performing sentiment analysis, right, so what does it basically do? Sentiment analysis, it assigns a weightage to each word, right? So saying whether it's a positive or negative in nature. So here we have two words, that is not and good. Okay, so now whenever it's assigning the weightage, so let's say the not actually has the weightage of minus 0.5, and the good has the weightage of plus 0.5. Okay, so when we take the complete weightage of this sentence, so it will give us as 0, right? But I mean, saying that, so what does this 0 mean? Saying that the sentence is pretty neutral. It's neither saying positive thing or negative thing of your mobile phone. But actually it's actually a negative comment, right? Saying that the phone's battery is not good. So we are unable to capture that negativity in this sentence, right? So what can we do? What are the additional steps that we can actually take to overcome this problem? So now what we'll do, I mean, previously what we used to do, we used to create a tokenized words like this. Like what we'll do, we'll use the phone's battery is not good, right? And then we will feed these tokens into sentiment analysis, and that will give us the sentiment value. But now what we can do, what additional step we can do is, we'll do one thing, we'll split two, I mean we'll be, because what was our issue, we were actually splitting not good into two separate words, but we actually need both these two in one word itself, right? So how can we do that? Let's do one thing. Instead of splitting each word into, all the words into separate tokens, we will create a two words like this. We'll create tokens like this: the phones phone's battery is okay. So we have created something like this. We have actually created tokens of two words here. The phone's battery is not good, right? So here we can easily capture that negativity in the sentence, right? Because we have not good in one token itself. So here it can easily predict that, okay, not good is actually negative word. So ultimately the final sentiment that we get out of the system will be negative in nature. It could be, it will be negative in nature, right? So that's how we can actually capture such things using this technique. So this technique is called as n-grams. So n is nothing but the number of words here. Okay, so if we split our sentence into like we did before, so these are called as unigrams. So each separate, each individual word in the sentence will be a gram in it. Okay, a gram in itself. But if we are building a bigram, what we'll do, we'll group two words together, and then we will classify that as a 1 gram. Okay, so this is the bigram of this sentence. So this is the unigram, this is the bigram of the sentence. Okay, if you want to build a trigram, then what happens? The sentence will look something like this: the phone's battery, and then phone's battery is, then battery is not, then is not good. Okay, so this is one such application of n-grams, right? So to capture the negativity or positivity in the sentence, we actually use bigrams. Okay, so this is one such example. The other example could be, so let's say, okay, let's take an example of the Gmail, right? So there is a new feature in the Gmail. It's almost been a year, but what a new feature in Gmail. So if you write something, so whenever you're typing an email, let's say you write the first two letters of a sentence, right? So what does Gmail does? I mean, it actually predicts the entire sentence what you might be typing and gives a suggestion to you guys, right? I'm sure you guys have observed it. So there, what's it's actually doing, we are actually building an n-gram model there, okay, in such a way that, so let's say I train a bigram model saying, let me write a sentence. Okay, saying, okay, so you are searching something in the Google, saying that data science, okay, let me write it, put it in this way: Python for data science. Okay, so so you want to search something in the Python, in the Google. Okay, so now what Google has done is it has actually split the words. I mean, it has actually trained a model by building an n-gram. Okay, it could be a bigram or trigram or whatever it is. So what they have done is, okay, so if we build a bigram out of it, Python for data 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 science, like this. Okay, so now let's say you write something like Python for, okay, so you will write it. So what it does, it will actually try to predict what could be the next few words, right? So what they have done is they are basically trained a bigram model here, such a way that if you write just, so as I was saying, bigram is not just one algorithm that we can use to do such things, because those are very complicated stuffs, right? So it is actually a combination of n-grams, and then there is something called as RNN, which actually comes in the deep learning. Okay, RNN is basically, again, it's a deep learning algorithm which can be used on text data to learn the sequence in the data, in a particular sentence, and predict what could be the entire sentence. Okay, so like that, we can actually integrate these n-grams into those RNNs and then build the models. Okay, which is very complicated, but I mean, we cannot just use n-grams to do such complicated stuffs, right? But yeah, so those are few of the applications where we can use these n-grams. So, but one of the major application was to capture that negativity or positivity in a sentence. Okay, so let's try to see how this we can actually build it in Python. Okay, we are not training any models here, but I'm just explaining how we can actually build n-grams. All right, so we will import a library called as n-grams from NLTK library. Okay, let's create a sentence. This is our sentence. Now let's try to build a bigram out of it. Okay, so initialize a variable n is equal to 2. So this is the number of grams we want, and then create one more variable, and then use the function n grams. Okay, use the function n grams, and then what is the sentence that you want to create a bigram out of? So this is the sentence dot split comma n. Okay, so what this sentence dot split does is it will just split each word in the sentence and put it in a list, and then this n-grams takes all the words in the sentence and then combines two words together like this. Okay, so now let's try to see what is the output of it. So all these bigrams are actually stored in this variable bigram, right? So let's try to see what are the what are the objects in this bigram. So just write a for loop for I in bigram, print I, right? So we want to just loop through all the objects in the bigram and check the items in it. So this is the output, right? So here you can see a contiguous and then contiguous sequence of n items from A I mean, the entire sentence is actually split into bigrams like this, right? So it's that simple to create n-grams in Python. Just use the function n-grams and you will have the output. Okay, so yeah, so I want you guys to open Jupyter Notebook and just try out this program, right? Because if you have any questions, we can clear it off here itself. So that's why I just want you guys to execute it here itself. And if you have any questions, just let me know. I'll explain it once again. Okay, all right. So just let me know once you are done, executing till here. We'll move on from that. Okay, the issue could be due to syntax. Okay, since I mean this is actually the older version of Python. So just what you can do is instead of print I like this, just write print I like this. Okay, I think that should solve your problem.
Okay, let me do that.
Can you just try that and let me know if it works or not?
Okay, 1 minute. Yes, good. It's work. Hello? Hello? Yes, that is okay now.
All right, great. So that was the issue. I mean, in the newer version, it's slightly different. So that's why I think you got that issue. Anyways, okay. So that's about n-grams. So the next two, yeah, no problem. So the next topic to cover is POS tagging. Okay. So why do we need this POS tagging, or what does it mean, right? So the POS is nothing but parts of speech. Okay, we're actually tagging the parts of speech to each a word in a sentence, right? So why do we need it? So the reason why we need POS tagging is, so there could be a situation where there is a word which is being used in different ways in different sentences, right? So based on the context, the meaning of the word could change. So what I mean to say is, so this is one such example, right? So the first sentence is, I love reading a book, right? In the next sentence, book a ticket to Bangalore. So here we have the same word book, which is being used differently in two different sentences, right? So the context here is different, the context here is different. So based on that, the meaning of the word actually changes, right? So if that changes, then the analysis that we are doing or the output that we're expecting could be different sometimes. So in that case, what we can do is we can actually capture the context here, right? So that's what we need to do. So how can we do that? We just need to tag a POS to each of the word. So let's try to do that. Let's see how we can actually do that. Okay, so this is the first sentence, this is the second sentence. So in order to assign a parts of POS, we need to tokenize it, right? So whenever you use any function in NLP, you always need to tokenize the sentence, because if we pass the entire sentence into any of the functions, the function will not understand what it is, right? So we need to pass a list of words to the function. So list of words is nothing but, so this is the list of words, right? So what is it? This is the tokenized version of this sentence. Okay, so first we need to tokenize each sentence. So this is for A, so this is for B, right? So I mean, once we tokenize it, so this is how the tokenized sentence looks like. Okay, it will split each word in the sentence, and it will be put in a list. So now let's skip it, this is not required. Okay, so just skip this sixth line. Okay, that was something I was trying. So now coming to the seventh line here, so we have the tokenized form of the sentence. So now let's try to assign a POS to each of the word in the sentence. So just create two variables, tags1 and tags2, and then use the function POS underscore tag. Okay, so this is the function to tag the parts of speech to the words in the sentence. Okay, and then POS tag pass the tokenized sentence into the function. So POS underscore tag first will pass for A tokenized and then for the B tokenized. Okay, so now let's try to see what are the POS that are assigned to each word. So in the first one, in tags one, you see that book has been assigned the parts of speech as noun, right? So the book is actually being used as a noun in the first sentence. In the second sentence, you'll see that book is actually being used as a verb, right? So as the the way we use the words changes, the meaning of the words used in the sentence also changes, right? So what we are basically trying to do here, we want to capture the context in which the word is being used. In the first one, it's being used as noun. In the second sentence, it is being used as a verb. Okay, so that's how we can actually use this POS tagging to classify the words, to which parts of speech it belongs to. Okay, so I'll just share this. Okay, at the end, I'll just share what are the various uh, POS tagging that can be assigned to each of the word. Okay, so here you see it was assigned as NN and VB. So VB is nothing but verb, and then NN is nothing but the noun here. Okay, I'll just share the notebook so that you guys can refer to this entire list, and then you can keep it with you for reference. All right, so just execute it, okay, so that you can actually see the results, how it's actually being done. Yeah. So first you import these two libraries, word tokenize and then POS tagging, which we'll be using for the below codes, and then you can start executing it. Okay, so just ping in a group once you guys are done.
I have a question.
Yeah, tell me, Santosh. Okay, it's a good question. So what is the difference between n-gram and tokenized? So in the tokenized, what happens every time, all the times, we're actually splitting each word, right? Each word in the sentence into separate token, right? But in the n-gram, we actually have that what I can say, additional functionality to control the number of words in each token. Okay, so here you saw that in each token there is only one word, but in the n-grams, sorry, my bad. In the n-grams, 1 second, I need to show that. Okay, so in the n-grams, even these are tokens, right? So the token is nothing but an individual word in the sentence. But since we are actually telling the function that we want two words in a token, so this will be considered as one token. Okay, so if we use that function tokenize, we just split every word in the sentence, and every word will be considered as a token. But if we use n-gram, then the combination of words will be considered as tokens. Okay, clear? Yeah, unigram is nothing but it's a tokenization only. It's like creating tokenization only. Does that mean like, okay, cool. Yeah, no problem. Yeah, so just ping in the group once you guys are done executing it. Yeah, sure, you can share your screen and just let me know what's the issue, or I'll just stop it for now. You can share your screen.
Okay.
Okay, so come to the last command. No, drag it down.
Okay.
Down. Show me the last sentence. Yeah, come down. Still down. Okay. Okay. Can you execute this one? NLTK dot download punkt. Just in a new cell. In a new cell, right?
Okay.
NLTK dot. No, come down. Come down. The last, right? At the last cell, just write cell in the new cell. No. Yeah,
Okay.
there, right? Uh, NLTK dot download. NLTK dot download. NLTK dot download within the quotes, within the, open a bracket, within the quotes, punkt. Punkt. Yeah, execute it. Okay, just so above that line, just write import NLTK. Just above the line you wrote, right? NLTK dot download. In the same cell, write import NLTK. In the cell 14 itself, just click on cell 14. Okay, it's that is okay. So just over above this line, just write import NLTK. Or it's okay. You first execute the next line, import NLTK, and then execute this. Execute the next cell, import NLTK. Yeah. Okay, now execute line 15.
Line 15. Okay.
Yes. Hold on a second.
I think that's it
It's
now.
still
Okay.
executing. Let's wait for some time.
Okay.
You
I'm
see a
waiting.
star over there, right? So that means the code is still running. So you need to wait until it gets completed.
Okay.
So what this punkt means, I mean, so whenever you install Anaconda, right? So it automatically installs the various required packages. But sometimes we don't actually, because of the version issues, all the packages might not be downloaded sometimes. Okay, so that's why you might get this issue. So if you get something like this, it'll actually suggest you saying that this library has to be downloaded first. In that case, you can just download these
Okay.
libraries and then
Yeah.
try to execute the sentence, that code again. Okay, it's still executing. Okay, so that was the issue. Okay, so once this is done, you can go back and execute. Okay, now go back and execute the above one, which or in which you are getting error. Yeah. Yeah, it got executed now, right? So now just try what is in A tokenized and what is in B tokenized, and you should be able to see the correct results. Yeah.
Yeah.
Got it,
I think
right?
that is now okay. Good. Okay. Thank you.
You can stop sharing now.
Yeah. Okay. Mm,
Or else that is okay. I can actually take control. I'll share my screen.
Hello,
So
guys.
I think you guys have, I mean, might have already seen so this in many places, right? So this is nothing but is called as word cloud, right? So why do we need such why do we need word cloud, right? So like let's go back to the same problem statement, right? So you actually I release a new product in any e-commerce website, right? So people start commenting on the product. Okay, so now you want to analyze whether people are talking bad about it or are they talking good about it. If they are talking good, what is that thing of which they are talking good about, and what is the bad thing they are talking about, right? So for that, what you basically do, you just go for the sentiment analysis to check the sentiment, whether it's positive or negative, right? But if you want to highlight those most commonly used words, right? So let's say they are saying, okay, the phone's battery is very good, right? So if it is being used most number of times, then those words will be highlighted in the word cloud, right? So now if you want to present something to the client or present something to the customer, or I mean, like what is that most common thing people are telling about the product, you can just use the word cloud, saying that, okay, people are actually talking positive things about your product, and the most positive thing that they're talking about is the screen, the screen's touch capacity is very good, or the phone's battery is very good, stuff like that. Okay, so in that case we can actually make use of this word cloud, right? So again, it looks like, it's very fancy, but the implementation of this word cloud is very simple. Okay, it's very simple. So let's try to implement it and check how we can actually build a word cloud like this, right? So what I'll do for this is okay, we can actually use the data set that was already given to you guys. I think it was a reviews or Twitter tweets or whatever data set it is. Okay, that is fine for us. I just need this column which actually contains the tweets or the comments, right? So what I'll do, first load the data set. I'll take this. I need to perform all the pre-processing steps on it, right? So perform the pre-processing steps, and then what I'll do, uh, I'll do one thing, since because building of word cloud actually takes a lot of time, right? So what I'm doing, I'm just building a word cloud on the first sentence itself. Okay, only on the first sentence. So I'll just create a new variable and get the first sentence. So train of the column name col, and then within the bracket I'm mentioning 0. That means I just want to subset only the first sentence, and I'll put it in the a. Okay, so now what I'm doing, I'll import the word cloud. So word cloud is the library from which we'll be importing word cloud function. Okay, so from word cloud, import word cloud, and then I'll be importing matplotlib as well, to make this word cloud much more attractive. Okay, and then let's build a word cloud. So define a variable. So this is the variable name. Okay, so don't get confused with the library. So this is the variable name. You can mention whatever you want here. Is equal to word cloud is a function here. Okay, we want that function, and then mention with the width, the height, and the background color, and the minimum font size. Okay, so this should be the minimum font size. So whatever could be the maximum size, the minimum font size should be 10. Okay, dot generate on the first sentence that we have here, right? So this is the first sentence, so generate on this sentence. Okay, so now the word is built here itself, right? So now we want to, we want to print it on the screen, right? So for that we will use matplotlib. Okay, so plt.figure, mention the figure size as 88, and then face color as none. Okay, and then write plt.imshow image show, and mention the word cloud name here. Okay, so whatever variable name you use here should be mentioned here as well. Okay, plt.imshow and the word cloud. Okay, and then mention plt.access is equal to off. We don't want access here, that is fine. And then plt.tight layout pad is equal to 0, just to contain everything within the screen or within a stipulated space. We do that, and then just use plt.show to display the image. Okay, so it's as simple as that. Building a word cloud is as simple as that, right? So but before that, what you need to do is you should clean the data first. Okay, otherwise if it contains a lot of special characters like hashtags or at the rates, then sometimes that will be displayed, which is not desired, right? So now what you can do is you can later on, once you're done with the class, you can just do it on the entire data set. But for now, what you can do is just create a random sentence. Okay, let me give that sentence as well. Just a second. Okay, so for now, let's do one thing. Let's build it take this sentence. Okay, so take this sentence and then define a variable like a is equal to, this has to be within the strings. Okay, because we're actually defining a text here, right? So just put it inside a, okay, and then execute this code. I'll just share this code. So first what I need you guys to do is first create a variable a and then write that that's the tweet that I sent. Okay, and after that in the new cell, just execute this line of code, the word cloud. Okay, and you should get a word cloud something like this. I mean, the words will be different, but you should get a word cloud like this. Okay, so just let me know if you guys are facing any issue or if you got the word cloud. Okay, in the no module found error. So that is because I think word cloud is not installed in your system. So what you can do is just use this one. Okay, pip install word cloud. Okay, so once you execute it and then try it out, you should be able to generate it. Are you sure? Did you execute the first one, pip install word cloud? Actually, it will take some time to download itself. Okay, I think it was not installed properly. So that was the issue, I guess.
Yes, I did it. Let me try
Okay,
again.
so what you can do is just execute this first. We need to download this. Okay, so first install pip install word cloud. It will take some time. Okay, wait for it. Once that is done, you can go back and execute the these lines of codes. Import from word cloud, import word cloud. Okay, so that's the issue for sure. So just wait for it to download. It will take some time. Okay, because the library is actually it's actually a pretty large in size, so it will take some time. So wait for it. So once that is downloaded, you can then use that library to build it. Okay, so that will solve your problem, but you can give it some time to download it.
Okay.
Okay, all right. So those were the topics that I actually wanted to cover for today. Okay, actually the next topic would be to start off with Excel, but the thing is I actually need an entire 2 hours. Okay, because if I do half today and then half tomorrow, I mean it won't be that good. So what we will do is we'll stop off at NLP today. Okay, so in tomorrow's class at the straight 2 hours we'll finish off Excel. I mean, we'll start Excel and we'll try to finish it off if we can. Okay, otherwise we will see how it goes. Okay, so let's wind up today's session. I hope everything is clear, and just go home and try to build this word cloud and the entire data set. You can take that reviews data set and execute it. So so that you guys can actually see how we can actually use it in the practical applications. All right, so let's wind it off. I'll meet you guys in tomorrow's session.
Thank you for attending the session. I hope you all enjoyed it. Don't forget to visit our Vimeo page and follow for more upcoming videos.